15.3 AS Mathematics Definite Integration. So we have already looked at indefinite integration. So indefinite integration is where you get an algebraic answer. So that's what we did in 15.1. So now we're going to have a look at definite integration, and what we end up with are limits on the integral. Okay, so if you look at this question here, we have an upper limit and a lower limit, and they are written at the top and the bottom of that integral sign. So you know when you've got indefinite integration because you've got the integral sign and then the dx without any limits on it, and that gives us algebraic, and it has to have the plus c on the end. Okay, so the answer to definite integration is a number rather than an expression. That's why it's definite. And to work out this number, we integrate in the normal way, and then we substitute the two values in and subtract. We will put a meaning on this later, but what it is actually doing, if we want the graphical reason for it, is it's giving us the area beneath the curve. So if we have some sort of curve and I integrate between two values a and b, it will give me this area here. Okay, so again, linking it to the velocity time graph, we've been working areas out beneath the curves, and this is how the non-uniform acceleration is going to progress in that topic. So there is a link there for us to have a look at. For 15.3, don't worry about the process in terms of what it applies to, just worry about how we get through finding that definite answer. So let's have a look at 3.1. So the first thing that we're going to do is integrate. So we do add 1 to the power and divide by it, just like we did before. And then if we just put the plus c on, it says in the notes above that we don't need the constant. So the arbitrary constant, we can drop it, and I'll show you why that is the case now. When we have integrated, drop that integral sign, but put some brackets on this and copy your limits down. What we do, obviously those threes can cancel, is we substitute in the upper limit, so we get 2 cubed. And then I substitute in the lower limit. I'm just going to leave it as 1 cubed for now. And then we subtract. So we're doing that limit, take away that limit in the expression. Now, when we do that numerically, I've got 8 take away 1. So the answer is 7. Can we see that the plus c here, so that one gives me that, but because of that minus sign, and it will always be a minus sign, the plus c's will cancel. So we don't need the c when we are doing definite integration, because it will cancel doing it this way. Okay, if we have a look at the next example, so we integrate in the same way. So we add 1 to the power and then divide by it. This time I'm not going to bother writing the plus c, but I put my square brackets round it. If you know that you are forgetful and you're going to forget the plus c, you are better to write it in every time and cancel it down, because you will lose marks on the other type of question, on the indefinite integration, if you don't put the plus c on. Okay. However, if you kind of get into the habit of you're either going to write plus c or square brackets, then you should be able to work with it from there. We're substituting the value in, so we've got 4 squared over 2 plus 3 times 4 for the upper limit. Take away, you have to get these the right way round. We've got minus 1 squared over 2 plus 3 times minus 1. Okay, so that is taking me to, we've got 8 plus 12 there. And then that squared and that minus 1, so it goes to plus a half minus 3, which is 45 over 2. Okay, you see I've got the calculator set up here. If you have a look, we have this button. So you can't do indefinite integration on your calculator, but you can do definite integration. So to use this, 3, you've got the X there. I'm doing example 3.1 again. And then to put the power on just like you would do in the normal way. Scroll through and you can enter your limits. And then when you press equals, it will give you the answer. Now, you can't, if you just write the answer down in the exam, you will not get any marks because obviously they're aware that you've got a calculator, and like we can train most people to do, use the calculator to press buttons, but it is perfect for checking your answer. So do use your calculator to check. In terms of the exam, it will say using algebraic methods find. So it will prompt you to have to show this working out, and but you use your calculator to check. So do that, because you don't want to make a silly mistake, because then you'd be able to go back through and see where your mistakes come from. In terms of showing the working out, what they're looking for is there's marks for the integration, then there are marks for the substitution and for the subtraction. So you need to show that, which is why here, if you look at this line of working, I haven't bothered simplifying anything down. I've literally saying to them, look, I am putting that upper limit into my expression, and then I'm putting my lower limit in and I'm subtracting, because that is worth method marks and it will pick up the accuracy marks. If you substitute in and mentally calculate something wrong, so for example, I'm putting -1 into here and therefore I get -1/2, because you've put it into your calculator without the brackets, then you will lose the accuracy marks, whereas I've got a chance of picking them up just by substituting it in. Okay, so you can check both answers just by using that X button there and then scrolling through. And obviously as these get more challenging, then that would be quite useful. 45/2. And then in the exam, you can give yourself a little pat on the back because you know that you've done that bit correctly. Okay. There is an exercise here for you to work through. So I will put the answers up. Instead of use integralcalculator.com, just use your calculator. That's just come from the olden days where we didn't have a calculator. So that integral calculator is just a website that does the same as what your calculator is doing. So just use your calculator. Okay. Okay, so you need to pause the video and have a go at that exercise. And there are the answers for you to check, although if you've used your calculator correctly, you will already know that you have the right answers.